Hi, ArcfieldWeather.com meteorologist Paul Dorian here. We are now in the middle part of the month of October, and it's time to look ahead to what may be in store for the winter season of 2025-2026. We'll talk about many of the factors that I've analyzed, and the winter outlook posting is right now available at ArcfieldWeather.com. I'll kind of walk through that actual posting. I will not go through every single plot or graph that I have just for the sake of time. So certainly feel free to go back for the text, to go back for some of the plots that I will not go through in this video discussion. Again, right there at the homepage of arcfieldweather.com. First of all, let's start up front here with some of the key factors involved in this winter outlook. As has been the case much of this decade, the winter season looks like it will feature La Nina conditions in the equatorial part of the Pacific Ocean. For the most part, it looks like a weak La Nina, but that's colder than normal water temperatures out in the central part of the tropical Pacific Ocean. And that has been the case for 4 out of the 5 winters this decade. The La Nina has kind of dominated this particular decade. Now, one thing of interest, it looks like this weak La Nina could transition into virtually neutral territory or nearly normal water temperatures during the second half of the winter season. So we'll talk a little bit about that and what the possible ramifications could be during the second half of the winter season for that transition, that likely transition from weak La Nina to neutral. Now, it's not the only area that I take a look at with respect to water temperatures. The tropical Pacific. I also look at the northern Pacific and, of course, the Atlantic Ocean as well. Northern Pacific is featuring a large area of warmer than normal sea surface temperatures, kind of analogous to what we saw about 10 years or so ago, a little bit more than that, maybe the winters of 2013, 2014, where we had kind of a warm blob, a large area of warmer than normal water tucked in just south of Alaska. It's not quite that extreme, but it's a little bit reminiscent of those particular winter seasons. We'll see how things evolve over the next several weeks as we head into the winter season. Now, in addition, I always like to take a look this time of the year at what the prospects are for high latitude blocking during the upcoming winter season. Now, high latitude blocking is characterized by higher heights than normal, higher pressures than normal, in the areas such as Greenland, Iceland, northern Canada. With high latitude blocking, those particular areas will be warmer than normal. But the high latitude blocking is quite important because if you have frequent high latitude blocking events during the winter season, you have an enhanced chance of colder than normal weather conditions across the central and eastern U.S. With high latitude blocking over that part of North America, like Greenland and northern Canada, it increases the chance that colder than normal air masses will be able to make their way from northern and western Canada all the way into the U.S. So by looking at some of the trends of teleconnection indices, such as the Arctic Oscillation or the North Atlantic Oscillation, this time of the year during the fall season sometimes can give a clue as to what to expect during the upcoming winter season. So we'll talk a little bit about that. Even solar activity, the sun is very important. Of course, it's the main driver of all weather and climate, and it even has an impact on a strong correlation seen between the solar activity levels and the prospects for high latitude blocking. In this particular year, we expect to see high solar activity during the winter season. That is not correlated with high latitude blocking. It's kind of the reverse. It's much more of a signal for the lack of high latitude blocking. So we'll talk a little bit about that. Also go into another teleconnection index known as the quasi-biennial oscillation. This specifically has to do with tropical winds in the lower part of the stratosphere, way up in the atmosphere. The lower stratospheric winds over the tropics has some correlation. It has been found to show some correlation with the polar vortex. And in this particular case, looks like we're headed into a winter season with what can be called a negative or an easterly phase of the biennial oscillation. And that favors kind of a polar vortex disruption. And we'll see in a few minutes here that typically is correlated with a displacement of the polar vortex from the North Pole, and in this particular case, down to, let's say, the Hudson Bay region of Canada, which in turn tends to favor the possibility of cold air masses making their way from Canada into the U.S. And finally, as I always do in long-range forecasting, I try to select some analog years, those particular years in which the sea surface temperatures, or what I expect to see for the sea surface temperature anomalies during the winter season, are similar to some years in the past. I've gone all the way back to the 1960s and selected about 5 different years that not only feature weak La Nina in the winter season, but those particular years were kind of surrounded by La Nina conditions, as has been the case during much of this decade. And I've also taken a look at those analog years with an eye on the quasi-biennial oscillation. A couple of those years had very similar QBO values that I expect to see this upcoming winter season, specifically negative numbers here with respect to the QBO. And by looking at the temperature and precipitation anomaly patterns during those analog years, can kind of get a clue in some cases as to what to expect during the upcoming winter season. Well, now just scrolling down this posting, again, it's out there at arcfieldweather.com. Let's first take a look at the sea surface temperature anomalies as of right now. This is as of the middle part of October. This is the west coast of South America right here, the equator right along this line right here, and we have colder than normal water temperatures, your La Nina conditions as we enter the middle part of October. And it looks like this kind of a pattern will continue at least into the beginning, the first half of the winter season. I mentioned earlier, much of the northern Pacific featuring warmer than normal conditions. And again, some of those winters about 11, 12 years ago had a lot of warmth in the water just tucked in south of Alaska, so we'll continue to monitor that. Much of the Atlantic warmer than normal, especially the Gulf and Caribbean Sea right now, which, by the way, leads me to believe we're not quite done yet with the Atlantic Basin tropical season. Certainly looks to me like there can be another homegrown system or two during the latter part of October, maybe starting off in the Caribbean Sea and the Gulf, and perhaps an impact on the East Coast. But that's a topic for another day. But right now, these are kind of the key players with respect to sea surface temperature anomalies around the world as we enter the middle part of October. Now, those were the sea surface temperature anomalies as of right now. What about the future? This is a compilation of numerous computer forecast models, both dynamical and some statistical. Computer forecast models tend to rely more so on equations, and dynamical more so on observations are fed in, especially current observations. And this is kind of a compilation. The thicker red line here is an average of the dynamical models, and the thicker green line here, an average of the statistical models. Now this line right here, this is the zero line or the neutral line right here. Anything above is El Nino, and anything below is La Nina. So you can see we're slightly below. We have a weak La Nina right now, and these are rolling 3-month averages. So December, January, and February right here. For the most part, they're all showing weak La Nina conditions. By weak, I mean maybe a half a degree or so below normal in terms of the water temperature. And the interesting thing is not only do they pretty in general agreement show this weak La Nina as we enter into the winter season, but they typically, generally climb up to near neutral here, especially the dynamical models here in this time period here. We're talking about maybe March, April, May, the second half, the latter part of the winter season. So pretty much a general agreement by all these models for weak La Nina as we go through the first half of the winter season. Then maybe kind of a change to neutral. And to me, that suggests a possibility of perhaps a backloaded winter season. By that I mean much of the snowfall in, let's say, the mid-Atlantic region could fall in the second half of the winter season. In other words, the transition from weak La Nina to neutral will kind of boost the atmosphere in the formation and the intensification of storm systems, perhaps during the second half of the winter season. So all of interest here, and again, it looks like weak La Nina that could transition late in the winter season to neutral. Now, I mentioned up front that this La Nina has been pretty dominating during this particular decade. This is a table of index values, and basically the blues or the negative numbers here represent La Nina conditions, and the reds or positive numbers El Nino conditions. And you can see here, going back to the beginning of this decade, we have predominantly negative numbers here, all but one of the winter seasons here. And it looks like this El Nino will continue right through the upcoming winter season. Perhaps it'll be weak, but nonetheless, La Nina conditions with colder than normal water temperatures out across the equatorial part of the central Pacific Ocean here. Again, this has kind of dominated the scene here for 4 of the 5 winters this past decade, this current decade, I should say. Now, let's just scroll down a little bit farther down on this posting right here. And I mentioned again about the high latitude blocking. And one of the ways we can get a clue about the high latitude blocking prospects for the upcoming winter season is to take a look at some teleconnection index trends during the fall season. In this particular case, I'm looking at the Arctic Oscillation and the North Atlantic Oscillation. Both of these have to do with temperature and pressure patterns up across the North Atlantic or the Arctic region, and they flip from positive territory to negative territory. And when both of these indices are in negative territory for a sustained period of time during a winter season, that is pretty well correlated with high latitude blocking. And it has been found that if they are negative, for example, for large periods of time in the fall, that usually happens in the winter. Or if they're positive for large periods of time in the fall, that usually happens in the winter season. So I kind of want to take a look here. And it's hard to tell in this particular plot, but right here is the neutral line. And you can see the Arctic Oscillation has generally been hovering around the neutral line. So this is a neutral system, a neutral signal in terms of the possibility of high latitude blocking events during the winter season. Now, the NAO, on the other hand, has been usually negative, slightly negative. In fact, in recent days here, it's kind of plunged well into negative territory. So I will call this a slightly positive signal with respect to the possibility of high latitude blocking events during the upcoming winter season. So I've taken a look here at a couple of index values, and there's also other things you can look at this time of the year, including snow cover, which I won't go over in this video discussion, but I have kind of a change in the snow cover across Siberia, for example, which has been found to give some clues as to the possibility of high latitude blocking during the winter season. Now, I mentioned solar activity, and again, the sun is crucial, of course. It's the main driver to all of weather and climate. The level of solar activity during the winter season has been pretty well correlated with high latitude blocking in the case of solar minimums, and no high latitude blocking, or very little in the way of high latitude blocking, in the case of solar maximums. This particular plot, what we're looking at here, 500 millibar height anomalies during solar minimum time periods, and you can see this orange right here over Greenland. This is higher heights than normal, higher pressures than normal. The classic signal of high latitude blocking. very clear signal here for solar minimum conditions. Maximum, quite the opposite. You don't see that signal. And we are in a solar maximum time period. So this is a negative signal. The level of solar activity, I believe, will be high during the upcoming winter season. So that's a negative signal for high latitude blocking. So kind of mixed signals when I look at the AO, NAO, and the level of solar activity expected during the winter season. Now, another important factor I've looked at here is known as the quasi-biennial oscillation. This has to do with the lower stratospheric winds over the tropics, and it is found to oscillate basically between what we call a westerly phase and an easterly phase. It may flip every 12 or 14 months or so, and there's been some empirical evidence that show the particular phase has an impact to the position, the strength, and position of the polar vortex. And in an easterly phase, which is ongoing right now and expected to continue into the winter season, a negative or an easterly phase, that has been well correlated with polar vortex disruptions. And by that I mean the polar vortex typically would be located right on top of the North Pole or right near the North Pole in the winter seasons with a negative or an easterly phase. It often is displaced, and in this particular case, we'll see in a moment here, some analog years show a displacement of the polar vortex down to the Hudson Bay region of Canada. And from that position, that'll act as a nice cold air source and increase the chances for colder than normal air masses to make their way from Canada into the U.S. In fact, if we scroll on down here, there's quite an interesting map here. This came from bamweather.com. This is the kind of the analog years when we have the combination of weak La Nina, which I expect as we enter into the winter season, and a negative QBO or an easterly phase of the QBO. And this is what we're looking at in terms of height anomalies all the way up in the stratosphere. We're at the 50 millibar level. I often show maps at 500 millibars in the middle of the atmosphere. This is the top of the atmosphere, the stratosphere. And what you're seeing right here is in these particular years, again, with that negative QBO and that weak La Nina, you have the displacement of that polar vortex from the North Pole, which is around here, down to being centered over the Hudson Bay region of Canada. And that certainly enhances the chance for cold air outbreaks to make their way into the northern U.S., which likely, in many cases, will spill their way into the mid-Atlantic region. So again, this is kind of a source of cold air source in this particular atmospheric setup here with polar vortex at the stratospheric level being displaced from the North Pole down across the Hudson Bay region of Canada. But that was a typical finding for these particular years, again, with a negative QBO and a weak La Nina. Now, I've mentioned that I love to select analog years to get kind of a clue as to what to expect with respect to temperatures and precipitation. In this case, this particular winter season, I've chosen 5 analog years going all the way back to the 1960s that featured weak La Nina conditions. And they were kind of in an environment with a pretty long-standing La Nina as we are going into this winter season. I've also taken a look at those particular analog years to the quasi-biennial oscillation. And kind of an interesting pattern has evolved here by looking at the temperature anomalies for those particular 5 analog years. Certainly a signal for colder than normal conditions here across much of the nation. Now, I don't necessarily agree with this, especially across the southern tier of states here. Typically in a La Nina winter, you oftentimes get a high pressure ridge over the southeastern U.S., and that leads in turn to warmer and drier conditions across the southern tier of states, let's say from southern half of California to Texas to Florida. So I don't necessarily agree with this, but it is quite a signal for colder than normal conditions that I do favor across much of the northern U.S., and that includes the mid-Atlantic region. Now, the coldest air this upcoming winter season relative to normal likely to be across the northern plains and the upper part of the Midwest, but quite an interesting result here with these particular analog years here with respect to the temperature anomaly pattern here. Now, let's take a look at the precipitation anomaly pattern for those same 5 years. And a couple of these years, again, had very similar QBO values that I expect to see this upcoming winter season, namely negative or easterly phase. Well, here is that signal that I do believe, I do favor here with a warmer, drier, in this case, drier conditions from California to Texas down to Florida, basically nearly normal in terms of precipitation amounts across much of the rest of the nation. Well, that takes us to kind of the bottom line or the conclusions. Again, I urge you, if interested, to go take a look at the actual posting with some of the plots I have not gone through in this video discussion, but you can review the text as well. In summary, I do believe the northern U.S. will be colder than normal, and that includes the mid-Atlantic region, perhaps in the range of a degree all the way down to maybe 3 degrees below normal in some of those mid-Atlantic locations, let's say from D.C. to Philadelphia to New York City in that December, January, February, maybe March time period. Again, quite a strong signal for some colder than normal weather across the northern U.S. And again, the main emphasis of the colder than normal weather looks like it'll be across the northern plains and the upper Midwest, with the coldest relative to normal in that part of the continental U.S. Now, in terms of snowfall, I do believe precipitation amounts expected to be nearly normal. We'll have nearly normal snowfall amounts, perhaps even a bit above normal snowfall amounts, and I list some of those values here for the big cities. Now, let me add this, that it is normal to get higher snowfall amounts in the northern western suburbs of the big cities, but in this particular winter season, it could be kind of markedly higher snowfall amounts in the northern western suburbs of the immediate metro areas, particularly in those far northern and western suburbs. Let's say, for example, Pottstown in the southeastern part of PA may get considerably more snow than the downtown Philadelphia area, or Rockville or Culpeper in D.C. as compared with the D.C. metro region. The reason I believe that is the negative QBO often leads to some coastal storms that, rather than being, let's say, 100 miles off the coast, kind of hug the coast. And whenever you have storm systems that hug the coast, that's much more difficult to get the snow accumulations in the big cities. But you go 20, 30, 40 miles to the north and west of D.C., Baltimore, Philadelphia, New York City, you can get significantly more snow than those downtown areas, if in fact a storm rides up right on top of the coast or along the coast. So expect that as a possibility here, that some of those northern western suburbs could get decent amount higher snowfall amounts than the big cities, where in the big cities, nearly normal to even slightly above normal. Now, elsewhere, we talked about the warmer and drier conditions that I expect to see across the southern tier of states. That extends from California to Texas to Florida. A La Nina winter, again, oftentimes has that southeastern U.S. ridge, and that'll certainly help to contribute to warmer and drier conditions across the southeast and the south central and the southwestern part of the nation. So that's it for now. We'll certainly monitor all of these factors over the next several weeks and report on any big changes that evolve before we get into the winter season. But certainly go back to the arcfieldweather.com website to take a look at this posting. That's it for now for the 2025-2026 winter outlook. I'm meteorologist Paul Dorian.